the last part for today is completion of post hoc comparisons. Plan comparisons we go about in a very structured way and it's a very rigorous design where we lay out our plan comparisons before we even collect our data. Doing that gives us a bit of luxury in terms of allows for a more powerful test. And we don't take the penalties that we do when we willy-nilly do all possible pairwise comparisons. Once again, doing all possible pairwise comparisons, which is referred to as post hoc comparisons, is after the fact. You're doing them after you've collected the data and you're gone. That's like gone fishing to see if you can find some significant effects. We know that when we have, for example, our perceptions of government study, we have three groups, three means, and we have three possible pairwise comparisons, as we talked about last week. So we can compare the college with the undergrad, college to the grad, and the undergrad to the grad, right? So college to the undergrad, college to the grad, undergrad, and grad. Three comparisons, each with an alpha of 0.05. If I look at them once again as a family of comparisons, my alpha for the family of comparisons considered thought of as a collective, the chance of me rejecting the null hypothesis at least once for each of the three comparisons with alpha equal to 0.05 is actually 0.14. So roughly 14% of the time, or out of 100 studies, 14 of those studies will give me at least one significant effect, even though the null hypothesis is true across all possible comparisons. So we have to make corrections for this problem. And that's what post hoc tests do. They make it a little harder to reject the null hypothesis. Okay. Relatively straightforward. So as I said, well, I didn't say this. The tests that we use, and there's a number of tests, but since I'm a big fan of Tukey, we're going to use Tukey's HSD, honestly significant difference. Tukey was a bit of a cheeky guy, so I thought, it's a good test. I've used it in my work experience. So, and it's honestly, at the end of the day, you'll see in a bit, it just comes down to personal preference. But there are some important decisions to make when you get into SPSS and you do all possible pairwise comparisons. Okay. So the calculation is very straightforward. I calculate my honestly significant difference, which is how big the difference has to be between each pair of means. And that's referred to as Tukey's honestly significant difference. So I use my error term, or my within treatments, or within groups. As you know, I use these terms synonymously in a very sloppy manner. So I take my MS within treatments. I divide it by my n per group, which is little n. I have 9 subjects per group. Take the square root of that, and I multiply it by the Q coefficient. The Q coefficient is on Blackboard, and I'll show where it is in a sec. The 3 pieces of information I need there is really my DF within groups, or my within groups, or treatment or within groups, or error degrees of freedom, which in this case is 24, and the number of treatment means that I have. So let's go find our Tukey's table. Okay, so I go into the course information folder, and there are our tables, and there's Tukey's Q table. Tukey. So I want the alpha equal to 0.05 table. My K is 3. K always refers to the number of groups. And I have 24 error or within groups degrees of freedom. There we be. So just, whoa. Oh no, don't do that. Oh, did I do that? There we go. So I have 24 degrees of freedom within groups and 3 groups. So 3.53 is my Q coefficient. There's my 3.53. So I punch that into the formula. This is easy to do by hand. So if the difference between any pair of means is greater than 5.38 or less than negative 5.38, I reject the null hypothesis. Now, once again, this post hoc, willy-nilly. These are all really two-tailed tests. So I look at my means. College compared to the graduate is 25 minus 30, minus 5, which is not less than minus 5.38, which should be like minus 6, not significant. College and undergrad, no difference. 5 plus 5, not greater than 5 plus 5.38. Voila. The graduate students differ from the undergrads. 30 minus 20 is 10. 10 is greater than 5.38. I reject the null hypothesis. I basically reached the same conclusion in this case, although sometimes you don't. Okay. And here is the lovely write-up for the post hoc comparisons. It's a little funky. Means that have the same subscript are not significantly different. So college, grad, and undergrad, these three, there's no differences there, but there is a difference between B and C, which is the grad and undergrad. So there's where I see the different letter. Very funky. Okay. Now, let's go have some fun in SPSS. I'm not going to do the Excel. It's relatively straightforward. So here's our data. So once again, analyze, compare means, the one-way analysis of variance. Okay, so I'm going to clean out my, I had contrasts in there. Let's just do a reset. Let's remove. I don't want them anymore. Okay, so we're going post hoc here. So, okay, just canceling those out. Post hoc. Now, as you can see, I have a whole series of choices here. And we're just going to do Tukey. Lovely Tukey. Now, Chef A is the most conservative. That makes it really the hardest to reject the null hypothesis. Bonferroni, Tukey's, they're pretty close. And you also have, I'm not seeing it here. Some of them allow you to do equal variance. Some of them allow you to do complex comparisons, but we're not going to worry. We'll always do pairwise. So I picked that one. And alpha, you can actually change the alpha. We're going to stick with alpha equal to 0.05. This is some of the stuff is new to SPSS. And then I go, okay. And there we go. Undergrad and college do not differ. College and grad do not differ, but undergrad differ from grad. So it's a little tricky. When you see two means that are not together, they differ from each other. Whereas I can see these two don't differ and these two don't differ, but since I don't see 20 here or 30 here, that means that there's a difference between those two. That's how you look at it. Now this is where it can get a little fuzzy too. So let's say I go and compare means, one-way ANOVA, and I go, now this is a subjective decision. The LSD is Fisher's LSD. It makes no corrections at all. It's like doing t-tests. So let's see what happens when I do that one. It's the least conservative. I would avoid it at all costs. But this is just for demonstration purposes. Okay, according to this one, the college students differ from the grad students and the college students differ from the undergrad students. Also, the grad students differ from the undergrad students. So what's happening here is when I go to Fisher's test, all three groups differ from each other. So all pairwise comparisons are significant. And that's just a toggle, right? The only thing I did was, and it's available, right? The only thing I changed was I went from Tukey's to Fisher's LSD. Avoid Fisher's LSD because it doesn't make any corrections. And you can see if I do go with it, it produces a different set of results. Whereas with the planned comparisons and using Tukey's tests, the only difference was the grad students differed from the undergrads. Whereas if I do Fisher's LSD, it's not a drug. If I do Fisher's LSD, all three pairwise comparisons are significant. College is different from undergrad, college is different from grad, and undergrad is different from grad. Different story. All based on one decision that is a simple toggle of post hoc comparisons. So be careful. Go to Tukey's. Okay. And that is it for this. So practice assignment next, so you can work on that, and see you later.